Please, everybody stand up.
Okay, hi everyone. My name is Jon, and today I want to talk to you about fat controllers, or specifically how to trim them down to be a reasonable size. Now, controllers are a basic part of every Rails app that you actually build, because every request a user sends to your system has to pass through a controller. Now, if you know about the thin controller fat model principle, you might start your new application by writing really thin controllers and fat models, and everything's great at the beginning. But as time passes by and you have to add more features and fix bugs, code starts appearing in your controller that you didn't write at the beginning. Now, your controllers get bigger and bigger, and writing code is easy, but deleting code is hard. Moving code outside from the controller where you first wrote it is really hard to do. So, as I said earlier, my name is Jon, which is short for Yonatan. People think that's long. And you can find me on Twitter at Yonatan Bergman. And I've been developing Rails app for the past 2.5 years. And I battled with controllers through that time. I worked on 4 different projects for the company that I work for. And each time I had to battle again with controllers. At the beginning, everything was great. But as time passed by, the controllers became uglier and harder to maintain. So I work at the eBay Israeli Social Center. We're a Ruby shop at Tel Aviv. We work for eBay Inc., but we're a self-contained unit that develops natural social commerce applications. Now, natural social commerce is everything that you do in the offline, we try to bring into the online world. So we're a small shop. You can see we have a cool office in Rothschild Boulevard. We're currently 13 people and a dog, and she doesn't write documentation. I'm the tech lead for Social Tickets team. We build products around the concept of going to an event with your friends. We found out that ticketing or group events, going to a concert, going to a game, is naturally a social thing. You usually don't go alone to those events. You don't go alone to a game or a concert. You go with your friends. So we have several applications based on that concept of going together with your friends to events. Now, we work with eBay Tickets and StubHub, which is an eBay company. For the Israelis in the room, StubHub is the second largest ticket seller in the US and the largest marketplace for tickets in the US. So we're talking about millions and millions of users going and buying tickets. So a couple of months back, we were approached and asked, hey, we have a cool idea for a new project and we'd like to build it. And I love new projects. Greenfield projects are the best because you get to write code from scratch. Only this time it was a bit different because being our second StubHub project, we had lots of assets and things that we needed to share between applications and actually reuse in the controllers. So the application that we built is called StubHub Go Together, and it lets you create a group event, invite friends to the page using Facebook, email, or Twitter, and ask your friends what seats do they want to sit in. Your friends come into the page, and they can tell you if they even want to go to the game with you or not, and tell you where they want to sit and how much they want to pay. Now, after that, you go on and you actually buy the tickets or use our other application and actually collect money from your friends before buying the tickets themselves, so they won't have to pay you back during the show, which is a real hassle. Now, the application is live for a couple of weeks now, and we're really seeing a great effect on the users. People that would otherwise have come to the page and couldn't find what tickets they wanted to buy for the group actually open up the group event and ask their friends, hey, where do you want to sit? Decide together on the tickets and actually buy them, which is really cool. Now, this is the 4th application that I've built in this company. It was our first big client-side application, the first time we actually used Backbone in a real application. and their controllers are really nice, if you don't mind me saying. I'll just show you what we went through as a company. This is an image of our first controller from our first project. This is like what I like to call the main controller. It's a mess. I know you're thinking, the fuck? Now, it has 470 lines of code and 33 functions, and that was after we refactored the hell out of it. So we got better. Each new project we did, we tried to cut down the lines of code that we actually have, and we did pretty well during the project. We went all the way from 407 all the way down to 76. Now that's a big difference, and it even looks better when you actually look at the code itself. That's a success. Our new controller is only 76 lines of code and 8 different functions, and it's a result of a process that we went through in the company trying to get our code to be cleaner and nicer. Now, I want to go through some examples of stuff that we found helpful in cleaning down our controllers, and I hope you can see the coding here. So we'll go through some samples. This is the most basic controller you can ever have. It's just a create function that creates a new group event. It gets data from a user, creates a new event in the database, sends out a mail, and redirects the user back. Now, this has a slight problem. This line isn't that great. It's slow. It's really, really painfully slow, and the user has to wait for the email to be rendered and delivered before he actually receives a response from the server telling him to go to the next page. Now, users actually don't like to wait, like we just talked about performance. They like to get things as fast as possible. Now, this also isn't something that controllers should do. If we, in the future, add another place that we can create events from, we would want this mail to be sent. But currently, as it's sitting in our controller, it won't be sent if we create a new event from a different controller or from a command-like task that we want to run. Now, we can delay it, put it in a queue using delay jobs, rescue, or whatever queuing system that we actually want. And the users will be happier because the performance is back up, but you won't be happier because you still have this piece of code inside your controller which you don't want to have there. Now, the most basic thing we can do is actually move this email send from the controller into an active record callback inside the model itself. Now, this will solve the problem. Our controller will actually now look great. It won't have any reference to the email being sent, and if we, down the line, want an event to actually send out a mail, even when we're creating it from a rake task, it will do that. But now we just offloaded the problem onto our model class. So what we found was the most helpful was to actually extract that behaviors and extract that method into an observer. An observer is just a class that uses Rails to look at and bind to events on the Rails system and actually do specific behavior when certain events occur. In this case, we use a mail observer to send out an email every time we create a new event. Now, this is cool because our event class doesn't have any reference to that behavior even occurring, and it's very clean. It's also easier to test because now we can turn the observers on or off on the test, and we can test this class in complete isolation. And testing is cool. So when you write code, you should be very conscious about what your controller does. A controller should control the workflow and control the communication between the user and your system. It should receive the request, parse out whatever it needs to parse out from the request, be it params or any other headers, and it should decide on what response to send back to the user. Now, it can also save out data on the side if it needs to, but primarily it should be concerned about the request and the response and nothing else. So let's go on to a different example. Some weeks have passed by, we've added some more functionality into our project, and now our controller is looking a bit bloated again. Sometimes most of the times actually, the Rails defaults are great for creating models and objects. And it's really fun to be writing a Rails application where the defaults make sense. And when you have a form, you can easily create a model from it. But sometimes you have to refine those form data. Sometimes you need to slice up the params hash and get only the attributes that you need. Sometimes you need to merge it with different form data because of client-side constraints. And when you're writing client-side code, nested attributes aren't always what you want them to look like. And sometimes you need to link up different models that you already have in your system. In this case, we added users into our system, and we want our newly created event to be linked to that user, who will now be the organizer for that event. Now, this code is a mess, and we might want even to have even more functionality inside here, things like custom validations, or things like more complex logic while creating events. We've had to encounter a situation where we needed find or create inside the nested models, and the Rails defaults didn't really help there. And from our experience, these things, the creation and update methods that we have in our controllers, are the first thing to blow it up along with your application, and they're the hardest thing to maintain and keep small. So we tried something new in our latest project, and we like it very much, and I'd like to share that with you. We extracted pieces of code into something that we like to call a creator. It's a terrible name, and it does more than create, and we're thinking of a better name for it, but that's our current name for it. And creators are actually pieces of code that build on the great Rails defaults and let you extract the functionality needed to actually massage the params into a new model and any other complex logic or validations that you might have while creating objects, and move that into its own separate class with its own separate responsibility, and make it easier to maintain, test, and actually develop more functionality above it. So creators are very simple. They just inherit from a creator, and it understands by itself which type of object you're trying to create. You can massage the params however needed using the refine params method, and whatever you do here will get sent into your model create method. You also have after and before filters, so you can change and add more custom code whenever needed. And actually using it is really simple. You just create a new creator, pass in the params hash and any other attributes you might need to create that specific model. Just call save, and if it passed successfully, you can now access your newly created event or model, and if it fails, you have access to all custom errors or all active record validation errors that occur during the creation process. Now, this is cool. Our controllers are smaller again, and we have something that's completely responsible to creating new objects. Now, we weren't happy with big chunks of code that we had, and it was hard to maintain it, and we figured out that it was growing too fast, and we can't manage the growth. So we solved our problem by inventing a new paradigm, inserting a new kind of object into the Rails system, and we like it. The only problem with doing that is that you might go over. You might create too many custom stuff, and you have to watch out for that. We don't think that this one was too extreme. We built on how Rails works to use most of the functionality, and we're pretty happy with what we have. Actually, just last weekend, I saw a tweet from Corey Haynes that got me to read about a cool gem called, I forgot, Red Tape, which does a lot of what we did in our creators, and we totally gonna look at it and see what we can build off that gem, which is already out in the ecosystem and ours isn't yet. Also, Rails 4 introduces a new concept called strong parameters, which moves the the security about what params you can send into the active record models from the model itself with either accessible or either protected into the controller itself. And now the controller is responsible for slicing and dicing the hash. And if you don't do that, it will throw an exception at you. I think that's cool, and you can already test it out by including the strong params gem into your gem file. So let's go on. Even more time has passed in our application, and we've needed to add a new kind of model that we call invites. Invites are whatever you send out to your friends. You created a new group event, you now want to invite your friends to the page to vote. So we added the invite functionality right inside the events controller, but something stinks. Those new methods that we added, the create invite and delete invite, sound weird. They sound like we have cruddy functions sitting in the wrong controller. Even the routes look weird. Something here is off, and you'll feel it. So let's extract them. We can easily move these functions into a nested controller and actually use how Rails works to create invites easily out of the event itself. Our routes will look amazing because we only define a nested controller, and that's really simple. And our code looks amazing because, again, the events controller doesn't know about invites and doesn't have to care about it. And again, our tests are easier because we don't have to test invites in the events controller or events in the invites controller, and everything is separated and clean. Now, the only issue with extracting stuff to a nested controller is when you need to share functionality between controllers. And I'll talk about that in a second. So try and separate functions into different controllers, and specifically into nested controllers. We found that it's something that makes our code very clean. One of the ways that we got to such a small controller in our latest project is the fact that we moved each object into its own controller, and that cleaned up the code really, really a lot. And again, easier to test. So we extracted our new invitation into its own controller, and now we're faced with some big code duplication. Both the event controller and the invite controller need to be able to access the current event, loading the current resource needed in our application. Now, we don't like code duplication. It's hard to maintain, and it's not fun to maintain. And we might even have more shared functionality between them. Controllers have a lot of bootstrap functions in them to help you do stuff like authentication, authorization, loading resource, handling errors, stuff that you will probably need to access in more than one controller. Now, one way to fix it is to move them up into the applications controller or start inheriting from different controllers. And that's good for stuff that you need to share across your application. We like to put our user support errors up in the application controller because all the controllers need to be able to access those functions. But things like loading the current event aren't relevant for the user's controller, and you'd want to make sure that no one will be able to access stuff that he shouldn't be able to access. So a cool way to fix that is using Ruby Mixins. Now, a mixin is just a regular module in Ruby which defines whatever behavior you want to actually add into different classes. And we found it's really cool to use mixins and add functionality into controllers. Now, this is really cool because now we have our behavior, our shared behavior, extracted out into its own Ruby module, and we add it in whatever controllers that we actually need to. We can also add it in other stuff. For example, we had a localization mixin that we needed for our controllers, and we also added it into our mailers because that let us have some shared code between our controllers and our mailers, which we needed. But it's not great because there are stuff that Ruby mixins don't do nicely. We might want to have this new current event method as a helper method, or as a before filter. But now that we have it as a mixin, we need to add this code again into each one of our controllers that actually includes that mixin. And that makes us a sad panda because, again, code duplication, and that's exactly what we're trying to avoid. So we came up with something that we like to call controller supports. And unlike creators, they're not a piece of code and they're not a library. They're just the conventions that we like to use. We took active support concern, which is a Rails module that actually lets you work around some Ruby metaprogramming mess and have a clear and easy way to define some stuff that usual Ruby metaprogramming makes a bit complex, and decided on a file structure to help us support and extract common controller functionality into their own files. A support is very like a regular Ruby mixin. To change a mixin into a support, we just need to extend our mixin with active support concern. And once we do that, we can actually use our new functionality to run a block of code each time our mixin is included, or our support is included into a controller. In this case, we run the helper method function on the on the methods that we want to turn into helper methods. And now each time it will be imported into a controller, it will be automatically defined as a helper method, and that's really cool. Plus, we also get the dependency out of the box, which is really important once you start slicing and dicing your controller actions into different mixins. So we found that the mixins or concerns or whatever you want to call it is the best way for us to minimize code from our controller that doesn't need to be there into files which have a single specific responsibility: user support, error support, localization support. We have tons of them in our applications, and it makes it a lot easier to test each one of those, because when they're mixins, you can test them in complete isolation. And it's very obvious when and where to add new behaviors into your system. So these are only some of the things we do to get our controller code down. I talked mostly about loading and handling resources. We also have a lot of code around presentation logic, serialization, decorators, things like that. I couldn't get into it because it's only a 25-minute talk. But the important thing is that you can actually attack a specific problem, even if it's something broad, like our controllers are unmaintainable and we need them to be maintainable. And you can actually attack that problem and find different solutions to find each of one of your pain points that you have. Now we're also hiring. We're 13 and a dog. We want to be more. And if you want to join us, come visit us at the booth outside. We're also having a raffle for some eBay gift certificates. So you just throw in your business card and you're in the raffle. Thank you.
All right, anybody have any questions? Do you have any tips for Backbone, sort of Backbone clean coding tips?
Yeah, the thing that helped us the most with Backbone, with moving to Backbone, is something that I didn't get to talk about, but we used active model serializers and we wrapped it up with some other functionality, and that just cleaned up our code really much. In each location where actually the system has to write a JSON object back to Backbone, we wrapped it up with a class whose whole responsibility and whole settings is actually convert an active model into that specific, the set of specific JSON attributes actually needed for the application. And that just let us, that solved so many issues that we actually had with the fact that sometimes we want to add some more functionality for admins. Sometimes we wanted to have different functionalities for different views. And I think that's the best thing that helped us move to Backbone, and we can continue offline at our booth, and I can share some other tips.